Let's go ahead and kick this party off with a little review. And first things first, number one, use your fraction circles to model the fractions below, and you're going to choose true or false. Is it right? Is it wrong? Is it true? Is it false? Remember those fraction circles? If you don't, no worries. Go right back to your Schoology and click on Mrs. Adams where it says fraction circles. When you click fraction circles, it takes you straight to a fraction circles page. Remember, you can use the circles or you can click on the left and use the strips. Completely up to you. I'm going to stick to the strips for this first example. So, speaking of this first example, I want to determine if 1/5 is equal to 2/10. Is that true? Let's see. Back to my fraction circles or my fraction strips. 1/5 equals 2/10. There's 1/5 and 1/10, 2/10. That is equal. They are lining up at the exact same spot. So I am going to click true. I'm going to mark true. Use your drawing tool. Make sure that it's thick enough so I know for sure that you chose true. And please complete it as neatly as possible so you do not get confused. Let's keep going. Looking at the second problem, 1/4 equals 2/6. Let's go back to our fraction circles. I'm going to clear that off. 1/4 and 2/6. There's 1/6 and there's 2. Is that equal? No, we can see that 2/6 is greater. It's taking up more of the shaded area. So this time, I'm going to clearly mark false. Keep going for C and D. If you don't have to use your fraction circles, hey, that's fine too. If you already knew by looking at 1/5 and 2/10 is the same thing, go right ahead because we know that 1 times 2 equals 2 and 5 times 2 equals 10. Remember, we can multiply by the same number, our numerator and denominator, for an equivalent fraction. So if that makes sense and that's what you'd rather do, feel free. But if you have no clue what I was talking about, make sure you use those fraction circles. Go ahead, complete C and D. For number 2, we are going to solve using US traditional addition or subtraction. Guys, you will need a separate sheet of paper for this problem. Remember, on your own paper, don't try to use this. There's not enough room. Make sure that you are lining up your digits. So if I'm adding 5,468 plus 3,977, I'm lining them up together. See how they're right in line? And then when it comes time for me to solve, this is on your own paper, not this tiny space. What is 8 plus 7? Okay, 15. Starting with my ones column. Carrying that 1 there. 1 plus 6 equals 7. 7 plus 7, 14. See what happens when you try to write it on here? You have to squeeze your numbers together. Nobody likes that. Just go ahead and do it right the first time on your paper. 1 plus 4 equals 5. 5 plus 9, 14 again. Don't forget your comma. 1 plus 5, 6. 6 plus 3 equals 9. Using my text box on this line, I am going to type 9,445. Remember, you are solving these on another sheet of paper. You will need a separate sheet of paper to solve these problems. And pay attention to see if the equation is asking you to add or subtract. Make sure you're paying attention to those signs. Use a separate sheet of paper. No, you do not have to attach it, but I would like you to use a separate sheet of paper to solve it. Once you finish adding and subtracting, move on to number 3. In the number 457,379, the value of the 7 on the left. Remember, we're looking at value, and they're saying on the left, so this one. What is the value? What is it worth? I know it's in the thousands place, but what is the value of that digit? Yes, 7,000. Now, what is the value of the 7 on the right? This one here. What is the value? Put it on the line. How much is it worth? I know it's in the 10 spot, but you're telling me the value, the worth. How many times larger is the value of the 7 on the left, the 7,000, than the value of the 7 on the right? Let me give you a hint. Think of your powers of 10. How many zeros do you have that are different? Think about that. Another hint, if you multiply whatever number you get times what equals 7,000? That may help you. Not do your best, but try to put something on this line. Last hint, it's a multiple of 10. So if all else fails, put something on this line for C that's a multiple of 10. Once you finish, mosey on to number 4. Now, number 4, there are a couple of things that I want to remind you of first. So I am going to type a couple of hints. You don't have to, but it will probably help you. 1 centimeter equals 10 millimeters. Just 1 centimeter equals 10 millimeters. Something else that may help you. 100 centimeters equals 1 meter. And something else that may help. 1 meter equals 1,000. I know that's a big number. Millimeters. 1 meter equals 1,000 millimeters. You may want to write this down. I'll give you time now. Okay. If you need to, pause it to make sure that you have this chart. We are going to complete the table. We know that we have 5 meters. We also know that 1 meter equals 1,000 millimeters. 5 times 1,000 equals 5,000. That's already done for us. But we want to find how many centimeters. 5 times 100, because 1 meter equals 100 centimeters. But I have 5 meters. So I need 100 5 times. And using our powers of 10, if we're multiplying by 100, how many zeros will we add? Yes, 2. So 500 centimeters completes the table, because 5 times 100 equals 500. Now for 20 meters. Just like last time, let's multiply by 100. How many zeros will we need to add? Yes, 2. And if we add 2 zeros, we have 2,000. 20 times 100 equals 2,000. Don't let all the zeros and big numbers fool you. Use your powers of 10. This time we're trying to find millimeters. How many zeros will we need to add this time? 3, because there are 3 zeros in 1,000. So let's do that. We have our 20, and we're going to add the 3 zeros. 20,000. The numbers start off small, But once we add those powers of 10, things get a little large. All right, let's keep going. 43 times 100 equals, yep, 4,300. We're using our powers of 10. We added those 2 zeros. And how many zeros will we use for our millimeters? You got it. We're going to add 3. So this 43 quickly grows when we add these powers of 10. Also, our unit of measurement is getting smaller. We know a meter is so much larger than a millimeter. I want you to complete 9 on your own. And for a challenge, there's 10,000. Can you convert it to meters and then millimeters? I know that you can. Just a hint, if we added zeros to get to centimeters, I'm probably going to take them off to get to meters. Finally, number 5. Explain how you subtracted in problem 2D. Now, 2D is where you had to subtract using traditional subtraction. So you are going to tell me what are the steps that you had to take to solve this problem. Remember, you used a separate sheet of paper. So you should have the steps already in front of you. And I want you to tell me step by step. First, I subtracted 2 from 2 and got 0. Oh, that's really small. I know you're going to say, Miss Adams, I can't see that. First, I subtracted 2 from 2 and got 0. Then I subtracted 0 from 3 and got 3 in the tens place. You are literally telling me how you solve this problem. When you line this problem up, you subtracted 2 minus 2, then 0 minus 3. So yes, I want you to type out every step that you had to take to solve the problem. Once you're finished, turn it in and submit. And that is all she wrote.